Hi students, this is Mr. Yao. After we have learned about adding, subtracting, and multiplying functions, the next part will be a bit different. And today is going to be the introduction lesson to something called composition of functions. Before we do that, let's actually review something we have learned before, plugging in. So, prior knowledge A, find f of negative 2. That just means we're replacing all of the x with negative 2. That would be negative 2 to the fourth power plus 3 times negative 2 minus 5. The 16 in the front, the minus a 6, which is a 10 minus 5, it's a 5. Next, g of negative 1, replace the x with negative 1, so 3 to the negative 1 power plus negative 1 squared minus a negative 1. This is the 1, that's a minus negative 1, so it's a plus 1 again, that's a 2. In the front is a 1/3, so it's 1/3 plus 2, which simplifies to be 7/3. Now, the reason we're reviewing these is because we actually want to understand what is exactly happening with plugging in. So we have been replacing negative x. We have been replacing x with whatever number is inside the parentheses, because typically the function is f of x. So that means this x is actually going to be part of the function. And whenever we replace something inside this parentheses, that is going to be basically the new thing to replace to substitute the x. And today's lesson is kind of similar in that sense. So after the previous lesson, you should be very familiar with plug-in. Let's think about what it means. F of x is read as f of x, and f of negative 2 is read as f of negative 2. It means to substitute all of the x with negative 2. Then what about f of negative x or f of x minus 1? So it's actually the same logic here. It means to substitute all of the x with either negative x or x minus 1. So let's actually see some examples. Example 1. As you can see, now instead of x being inside the parentheses is negative x. That means wherever you see x, you're going to be replacing it with negative x. So f of negative x is going to be 3 times negative x minus 2. So that would be simplified to as negative 3x minus 2. So again, because this is negative x inside the parentheses, we are replacing x with negative x. So same idea. Next, f of x minus 1, that means wherever we see x originally is going to be replaced with x minus 1. And then we keep simplifying. So it's 3x minus 3 minus 2, which is 3x minus 5. There you go. That's example 1. Example 2, same thing. When it's f of a negative x, so we're going to replace wherever we see x with whatever we are now having inside parentheses. So it's negative 4 times negative x and plus 3. That's going to be a 4x plus 3. And next, f of 2x minus 3. Well, this time it gets a little bit more complicated because inside the parentheses is 2x minus 3. You have to understand this x is just a placeholder. It doesn't actually represent anything. It's just something to hold a place that is going to be substituted by whatever you have when we actually calculate a function or simplify the function. So now that x is going to become, so the negative 4 stays there. Now the x is going to become 2x minus 3. Then a plus 3 on the end. There's negative 8x plus 12 plus 3. Simplifies to be negative 8x plus 15. There you go. That's example 2. Moving on, example 3. So first, f of negative x. Inside the original function, x is right here. So we're just going to be replacing that with negative x. Everything else stays. So it's 2. So replace the x with negative x. One thing again, whenever you're substituting, just like when you were doing the system equations, whenever you're substituting, make sure you put it inside parentheses. So it's negative x inside parentheses, then square, and minus 4. To simplify that, negative x squared is a negative x times another negative x, which is x squared. So it's 2x squared minus 4. It's the same as original, but that's because whenever you square a negative something, it's still going to become positive. But we actually did plug in negative x. Moving on, f of x minus 1. That means we are going to need to replace the x with x minus 1. To be clear, whenever you do see something like this, the order of operation tells us we do have to deal with a square first. So whenever you see a square, my suggestion is write it twice. Because technically it is that x minus 1 times itself twice. So that's why we are writing it twice, so that we can actually do the distribution that we have just learned in the previous lesson of multiplying functions. Because one thing you have to be clear is you can't just square the x and the negative 1. It doesn't work that way. You do actually need to write it twice and then multiply through the parentheses. So we're now actually working with, you can either choose to multiply these two together, then multiply with the 2, or you can choose to multiply the 2 inside the first parentheses. 2x minus 2 times x minus 1. And then a minus 4 on the end. Okay, you can either use a box or a string method to deal with that multiplication. 2x times x is 2x squared. 2x times negative 1 is a minus 2x. Negative 2 times x is a minus 2x. And then negative 2 times negative 1 is a plus 1 with a minus 4 on the end. Simplifies to be 2x squared minus 4x minus 3. There you go. Next one is f of 2x plus 1. So it's very similar to the f of x minus 1. 2 stays, and then inside the parentheses we have 2x plus 1 being squared minus 4. So we see square, write it twice. 2 times 2x plus 1 times another 2x plus 1 with a minus 4 on the end. You can choose to multiply the 2 within the first parentheses, but since I already did that with the previous one, with the f of x minus 1, for this one, I'm actually going to deal with the 2 parentheses first. So we can actually do a box method, since I just did the string method. 2x, a positive 1, 2x, a positive 1, 2x times 2x, 4x squared. 2x times 1, 2x. 1 times 2x, 2x. 1 times 1, a 1. So the 2, remember, the 2 has to stay there because we didn't include it. This 2 has to stay in the front. We have only dealt with the 2x plus 1 times the 2x plus 1, which becomes 4x squared plus 2x and 2x together is a 4x, and then a 1 on the end. But don't forget, you have a minus 4 on the end. So now we can actually distribute in the 2, which is going to become 8x squared plus 8x plus 2 minus 4. Simplifies to be 8x squared plus 8x minus 2. That's example 3. Moving on, example 4. Well, now it's just more practice. So f of negative x. I actually suggest you to try to pause here and try this example by yourself. You can come back and check. So let's have a look. F of negative x, replace all of the x inside the original function with negative x. 3 times negative x squared plus 5 times negative x. Negative x being squared is going to be a positive x squared. So that is now going to be 3x squared. And then the 5 times negative x is just minus 5x. Next, we have f of x plus 3. 3, and the x plus 3 being squared, and 5 times, well, this x also needs to be replaced with x plus 3. Whenever you see square, write it twice. So we have 3 times x plus 3 times another x plus 3. Then on the back, we do actually need to distribute the 5 into the parentheses. That becomes 5x plus 15. Since in the previous example, the x minus 1 times x minus 1, I have dealt with the 2 in the front first. For this one, I'm going to use the other way, which is to multiply the x plus 3 and the x plus 3. So let's draw the strings. The 3 stays in the front. X times x is x squared. X times 3 is a 3x. 3 times x, another 3x. 3 times 3 is a 9. Don't forget everything we still have on the back, the 5x and the 15. But now we do need to distribute in the 3's with everything inside the parentheses. There are 4 terms, so 3x squared. But these 2 terms, well, 3x and 3x together is a 6x times 3. That's an 18x. 3 times 9 is a 27. And then the plus 5x, the plus 15. let me actually change this back so that you're not being confused. The 3 times 3 is a 9x first, then the 3 times 3 is another 9x. Eventually, combine like terms, 3x squared in the front, we have a 9x, another 9x, and a 5x. Together, that is 23x. Then the number, we have a 27 plus a 15, which is a 42. Now, the last one, f of 3x minus 4. Let's write it out. 3 stay in the front, and then the x minus 4 is going to replace the x. So 3x minus 4 being squared, plus a 5 times 3x minus 2. And since we're seeing squares, we want to write it twice. 3 times 3x minus 4 times another 3x minus 4 plus 5 times, well, I can actually open the parentheses on that part. 5 times 3x is a 15x. 5 times negative 4 is a minus 20. And since for the x plus 3, I have dealt with the parentheses first, this time I'm going to put in the 3 as a first step. So that's going to give us a 9x minus 12. And then we still have the 3x minus 4. And then a plus 15x minus 20. Since I just used the string method, I'm going to use the box method for this. It's going to be a 2 by 2 box. 9x minus 12, 3x minus 4. We have 27x squared minus 36x. Negative 4 times 9x is a negative 36x. The negative 4 times the negative 12 is a positive 48. Okay, so let's continue. 27x squared minus 36x minus another 36x plus a 48 plus a 15x minus a 20. Eventually, combine like terms. 27x squared, that's a negative 36, and a positive 15, which is going to be a negative 57x plus 48 minus 20 is a plus 28. And that is the last example for this lesson. Thank you.